Welcome back, everyone. It's great to have you here for another episode in our Unreal Engine 5 no-code VR authoring platform tutorial series. I'm Craven, and today we're diving into one of the most essential and often overlooked elements of 3D digital art, lighting. Lighting in Unreal Engine isn't just about visibility. It's a creative tool that can completely transform the mood, depth, and realism of your scene. It's truly an art form, and Unreal gives us some incredibly powerful features to work with. In this session, I'll walk you through a high-level overview to help you get started quickly. By the end, you'll be ready to jump in and begin adding lights to your own scene. Let's get into it. Unreal Engine gives us 5 distinct types of lights to work with, and today we're kicking things off with one of the most fundamental, the directional light. Think of it as your virtual sunlight. In most starter scenes, Unreal already includes a directional light by default. So let's quickly go ahead and create a new basic level. If you rotate your camera around, you'll actually spot the sun hanging in the sky. Pretty cool, right? To locate it in your project, head over to the outliner, open the lighting folder, and you'll see the directional light listed there. While you're at it, take note of a few other key elements. The sky sphere is what renders that beautiful blue sky. Volumetric clouds handle the cloud visuals. And the sky atmosphere is a special actor that brings all these pieces together. We'll explore each of these more in depth later on, but for now, let's stay focused on the directional light itself. Once you select it, try rotating it. You'll notice the lighting in your scene shifts dramatically, almost like changing the time of day. Lower the angle, and you'll start to see golden hour tones. Push it even further, and you can simulate a sunrise or sunset. Keep going, and the map transitions into nighttime, which introduces a whole new set of lighting considerations we'll cover soon. For now, experiment with rotating that light and watch your scene come alive with dynamic changes. It's a powerful way to set the mood and tell your story visually. Now let's take a moment to explore the Details panel, specifically under the Light category. One of the first things you'll notice is the intensity setting, which is currently set to 6 lux. Now, lux is a real-world unit that measures light per unit area. If you're familiar with how lux works in physical lighting, Unreal's approach might feel a bit off. For context, sunlight in the real world can range anywhere from under 40 lux on a cloudy day to over 120,000 lux in direct sunlight. That's affected by everything from the time of day to atmospheric conditions, and of course the fact that the sun is 93 million miles away. But here's the thing, Unreal Engine isn't trying to simulate physics with perfect accuracy. Behind the scenes, it's doing a bit of creative math and visual trickery to make lighting look good and behave intuitively. So don't get too hung up on the lux value itself. Instead, think of this setting as a creative tool. The default intensity in a basic scene is 6, but many artists in game development and film tend to bump it up to around 20 lux for a more visually impactful result. The key takeaway? Don't overthink it. Use your eye, trust your instincts, and let your artistic direction guide you. Lighting is as much about mood and storytelling as it is about numbers. Now let's talk about the Skylight, a special lighting tool in Unreal Engine that plays a very specific role in your scene. If you've worked with lighting before, this will feel familiar. Think of the Skylight as an HDRI environment light. By default, it captures everything visible in the sky, like the sun, clouds, and atmospheric color, and uses that information to create a high dynamic range image. That image then casts ambient light across your level. This makes skylights especially useful for outdoor scenes, where natural lighting really matters. To show you how it works, let's start fresh. Create a new empty level. You'll notice the viewport is completely black. No sky, no sun, no clouds. Let's drop in a simple chair from the starter content so we have something to light. Now head to the Quick Add menu, go to Lights, and add a skylight. You'll see the chair is still pitch black. That's because there's nothing in the scene for the skylight to capture. No sky elements, no light sources. So instead of relying on a sky that doesn't exist, let's define our own HDR image. Select the skylight, then open the Details panel. Change the source type from Captured Scene to Specified Cubemap. Unreal's starter content includes a sample HDRI cubemap, so go ahead and select that from the dropdown. Instantly, the chair lights up. If you double-click the thumbnail, you'll see the image that's driving the lighting. The bright areas of the image contribute more light, while the darker areas contribute less, creating a dynamic, 360-degree lighting environment around your scene. You can fine-tune this setup in a few ways. Rotate the cube map angle to shift the direction of the light. Adjust the intensity scale to control how much light is emitted. The default is 1, but even small tweaks make a big difference. Modify the light color to tint the overall lighting based on the HDR image. And finally, toggle the FX World checkbox. Let's jump into artificial lighting in Unreal Engine, starting with one of the most versatile tools, the point light. To begin, I'm grabbing a floor mesh from the Starter Contents Architecture folder. I'll scale it up to give us a nice open space to work with. Now, using the Quick Add menu, I'll drag a point light into the scene. So what exactly is a point light? Think of it like a light bulb. It shines in all directions, casting light outward in a full 360-degree sphere. The icon even looks like a bulb, which makes it easy to spot. Now, the reach of this light, how far it can spread, is controlled by something called the attenuation radius. This setting defines the maximum distance the light is allowed to travel. But here's the twist: just because it can travel that far doesn't mean it will. That part depends on the light's intensity, which follows a principle called inverse square dynamics. For now, just remember, attenuation radius sets the boundary, and intensity determines how much light actually fills that space. As you increase the attenuation radius, you'll notice that adjusting the intensity also changes how far the light appears to reach. It's a balancing act between the two. Now take a look at the intensity value in the Details panel. You'll see it ends with CD. That stands for Candelas, which is Unreal's default unit for measuring artificial light. It's a more physically accurate way to simulate real-world lighting. If you're more familiar with lumens, here's a quick conversion. 8 candelas is roughly equal to 100 lumens. Prefer working in lumens? No problem. Just type intensity into the Details panel search bar and switch the unit from candelas to lumens. Next up, light color. This does exactly what you'd expect. It lets you change the color of the light. You can go wild with creative choices, but if you're aiming for realism, try enabling Use Color Temperature. This lets you dial in warmer or cooler tones using real-world temperature values, which can make your lighting feel more natural and grounded. So that's your intro to point lights, simple and full of potential. Next up, we'll be talking about the spotlight. If you've ever worked in film or photography, this one's going to feel instantly familiar. You can add it from the Quick Add menu, just like the point light. And when it comes to settings, intensity, color, and temperature, they all behave the same way. The attenuation radius also works the same, defining how far the light can potentially reach. But here's where things get interesting. Unlike the point light, the spotlight doesn't shine in every direction. Instead, it projects light in a focused cone shape, like a flashlight or a stage light. The length of that cone is determined by the attenuation radius. The width, though, is controlled by the outer cone angle. Want a wider beam? Increase that angle. Want something tighter and more dramatic? Narrow it down. There's also an inner cone angle, which creates a second, more concentrated cone inside the first. This inner cone sharpens the light's focus, giving you more control over how soft or harsh the edges appear. Mastering the balance between these two cones, inner and outer, is where the real artistry comes in. Let's wrap things up with our final artificial light type, the rect light, short for rectangle light. This one's a bit different. Instead of casting light from a single point or cone, the rect light emits light from a flat rectangular surface. It's perfect for simulating things like a TV screen, a computer monitor, or even a ceiling panel light. You'll find it in the Quick Add menu, just like the others. And yes, intensity, color, and attenuation radius all work the same way here. But what makes the rect light unique are two key settings: size and barn doors. To shape the light source, you'll use source width and source height, both measured in centimeters. This lets you define the exact dimensions of the rectangle, giving you control over how broad or narrow the light appears. Now let's talk about the barn door settings. These allow you to frame the light, almost like placing shutters around it. By adjusting the angle, you can start to box the light in. Then, use the length setting to extend those doors outward, While it might look like you're building a softbox, and you can get that effect, the barn door controls are actually great for creating hard-edged shadows, similar to light streaming through a narrow opening, like an actual barn door. Now that you've got a solid grasp of the lighting tools available in Unreal Engine, you're ready to start shaping your scenes with intention and style. As we've touched on, cinematic lighting isn't just technical, it's an art form. It takes practice, experimentation, and a keen eye to truly master. Up next, we're shifting gears. In the following session, we'll dive into character creation using metahuman models, bringing a digital persona to life for our project. So get ready, and I'll see you in the next video.